Hello everybody, hope you're all doing well, and today we shall be doing a video on simplifying rational expressions. In this video we shall cover multiple examples of how to do this. So, if f of x is a polynomial, then f of x over ax plus b is equal to qx plus r, which will be the remainder, over ax plus b. Where q is also a polynomial to be found. So, we shall start with an example. Here we go. So, rewrite 2x squared plus 3x plus 4 over 2x plus 1 as ax plus b plus r over px plus q. Right, so we shall start with 2x plus 1 brackets, or, well, we shall be dividing 2x squared plus 3x plus 4. So we want to minus, well, we're going to start with the first term, so we'll be timesing by x to get rid of that. So we get 2x squared plus x, so we times by x there. And we're minusing this as a whole from our top function. So that will give us 0 for 2x squared, and that will give us 2x plus 4. Now we want to get rid of the 2x, so to do that we just timesing by 1, so plus 1, so we're minusing 2x plus 1, which will cancel off the 2x's and give us 3 overall here. So there we go, 3, and that means we can simplify our 2x squared plus 3x plus 4 all over 2x plus 1 as our x plus 1 here, which will be a qx from earlier, so x plus 1 plus our remainder 3 all over what we were dividing by, which is 2x plus 1. Which is jolly good. So hopefully you followed that. Now you can have a go at your own example. So if you'd like to pause the video and have a crack at it, feel free. Right, let's crack on with our division. So we're going to have 5x plus 3, and we're dividing 5x squared plus 3x plus 4. We'll be dividing that through by our 5x plus 3. So we're going to be minusing 5x squared plus 3x, as we're going to have to times by x to get that term to equal that. So times by x again. And we're minusing this off, which means that will cancel off, and you may have noticed that the 3x actually cancels off as well, which only leaves us with 4, making this a very nice example. This means that when we have 5x squared plus 3x plus 4 all over 5x plus 3, that will equal our term that we managed to actually divide out of it, x, which is our polynomial, plus our remainder, 4, all over what we were dividing through by, which is 5x plus 3. So yes, some nice examples there. Now we shall move on to one that's a little more complex in comparison. So here we So do have a crack at that yourself, see how far you get, and I'll go through it afterwards, see if you got it correct. Right, so we can actually change this and this to equal, so we have 2x squared minus x minus 28 all over x squared minus 2x minus 8. This will equal, if we factorize both parts, 2x plus 7 times x minus 4. Hopefully you can see where we got that. And then with the bottom one, when we factorize that, we shall get x plus 2 times x minus 4. Now, hopefully you've noticed a little something here. X minus 4 here, and x minus 4 here, and then a timesing, which means we can actually cancel them off, giving us a more simpler 2x plus 7 over x plus 2. And this we can work with. Excuse me. So if we have x plus 2 and we're dividing 2x plus 7 through by it, that means we shall, if we times by 2, we can cancel off our 2x, so we're going to be minusing 2x, 2 times 2 is of course 4, so plus 4 there, we times by 2, and then that will give us a remainder, so if 2x is cancelled off, 7 minus 4 is 3, meaning, that's just therefore in case you haven't come across it before, we shall have 2 plus 3, our remainder, over x plus 2. Hopefully you followed that and understood it completely. And now we shall move on to our final example, and let's see how you do with this then. So do have a crack at it yourself. Hopefully you'll get the correct answer. If not, that's fine. We shall go through it and I shall explain how to do it, and we shall get to the answer that we require. So hopefully you've had a crack. If not, that's fine. We'll go through it now, see if you can follow what we're doing. So we have got this function, we've got x squared plus ax plus 3, all being divided through by x minus 2. And if you read, if you read the question, it shows that we're going to get f of x plus b over x minus 2, which is not too hard, but it's told us that the remainder is equal to 5. So we will work through this as normally, as you'd do normally, and then we can put the remainder that we get is equal to 5, which, just looking at the question, I imagine will give us the value for a. So, first off, we need to get rid of this x squared. So what do you do to this when you want to get rid of x squared? Well, of course, we need to make x squared, and to do that we times this by x. So, yes, we put x at the top there. So we're going to get x squared minus 2x. And when you minus that from this, x squareds cancel off. We shall get a plus 2, because it's a minus there, and we're minusing that off, so it's minus of a minus, makes positive. A plus 2x, x term, plus 3, our remainder. And now we need to get rid of this, we need to get rid of all our x terms. So that means that to get from x to brackets a plus 2 times x, we need to times by a plus 2. So yes, let's do that. So we're timesing by a plus 2. Just keep track on top there. So that means we shall be minusing a plus 2x, but the thing is we've also got the minus 2 here, which we have to times by a plus 2, so we've got minus 2, a plus 2. X's cancel off, and then we're going to be left with 3 plus 2 times a plus 2, which is equal to 5, because of the question telling us that. So therefore, we'll simplify this down, so we'll get 2a plus 7 equals 5, meaning 2a equals minus 2, because 5 minus 7 is minus 2, which means a is equal to minus 1, meaning up here that means we've got x plus 2 minus 1. 2 minus 1, of course, is 1, which means we've got plus 1, which means that our final answer will give us our x plus 1 from here, plus our remainder, which is 5, don't we forget. Don't want to forget that, it's given in the question, all over what we were dividing by, which is x minus 2. So that is simplifying rational expressions. And I would have done partial fractions in this video as well, but I didn't want it to get too lengthy. But this simplifying rational expressions isn't too complicated, and my next video, which will follow on from this, will be covering partial fractions, going over a few hard and easy examples, which hopefully you'll be able to follow. So until next time, cheerio!